Hello, welcome to our next project, that is class assignment 2. Now I'm going to present my class assignment 2, that is uh, capture zone of wellhead. In our class, we calculated the capture zone and plot as a circular radius. Now we're presenting the capture zone considering the flow gradient at the direction of the flow. So this is our class assignment 2. This is the diagram of wellhead protection zone. So in this assignment, I want to actually make an outline that what we have already done in this project. Actually, we done in this project. We have the data set in our previous class. That is the transmissibility value. We have calculated the transmissibility value, and we know the water elevation, and we know the geometry, that is latitude and longitude, and that geometry is actually the geographical coordinate. So in this project, we convert this geographical coordinate into the projected coordinate, that is Albert's equal area conic projection EPHG 6350. So our target is to draw this capture zone boundary. This is our wellhead, and we need to calculate the stagnation point, and we need to calculate the y max is the maximum y direction value. This is the y max. So first of all, we import some of necessary library, that is we import numpys, pandas, and as well as these libraries. At first we create the directory. In my directory, that is already given here, and in the first we have uploaded our previous file that is completed in our class. I have imported some files. At the very beginning of this work, I actually make a geo data frame, and that is EPSG 4326, the file that already created in our class, and this is the file. Here we have calculated the transmissibility value, square feet per day, as well as the gallon per day per feet, and this is our aquifer thickness. At the first, I want to clarify that in this project we need to calculate our water elevation, that is hydraulic head, with respect to mean sea level. So this is the actually representation of hydraulic head with respect to mean sea level, and after that I convert it to the square feet to square meter of transmissibility value. The conversion factor is 0.0929, and after conversion I add this column separately in this file, and we selected our my well ID. My well ID is 6162305, and I extract my well data individually, and I found my transmissibility value is 307 square meter per day, and here hydraulic head is calculated this value. And after that my target to calculate the gradation, the regional flow, and for this calculation we need to add another file, and I added another file, and I extract the latitude and longitude, and this is my actually Albert equals area conic projection, latitude and longitude, and this is my hydraulic head. So after that, actually I have calculated the uh, gradient from the actually our regression value. So after running that regression, I found the regression coefficient value, and from this regression I extract a, b, c, the coefficient, regression coefficient, and I found this value. And after that actually I want to show you my file, and this file I choose this value, that is lead long hydraulic head, and in this three value I have made regression and found the regression value, and I found my data in my boundary equation. Actually from this equation uh, we have calculated this y max and y value at the wellhead as well as stagnation point distance, and I found this data is this is my summary data that is calculated. Maximum width of the capture zone I found is to 24,000 meter, that is 24 kilometer, and my converted transmissibility value is 307. This is the gradient and that I have calculated already by linear regression, and this is my Q, my targeted rate of pumping. In this pumping we considered the population 20,000, and per capita consumption is 135 gallons per day, and I calculated this in meter cube per day and made a conversion factor here. After getting this value, my target is to draw this capture zone, and I actually take this value and this boundary equation that is given for the calculation of the boundary, and I put first I put it, this value is the wellhead point, the y value, and I run this file, and I get a well shape wellhead protection areas. In these areas, this is the stagnation point, and this is the origin 0 0, the wellhead that is considered as 0 0 this point. And after that, in this file I get a problem whenever I put this y max value, that is found 24 kilometer. It makes a problem to, for the plotting, and after that I reduce this value in 20 kilometer, and within this 20 kilometer it get a well shape, it plotted a well shape, but I don't know in this boundary equation what is the problem is whenever I put in this 24 kilometer I get irregular curve shape, and this is the I double check that my gradient is okay or not, and I found the same, and the coefficient, that's okay. But after that I again calculated a round shape of y max 20 kilometer, that is a good curve, and this is the x value that created in this from this boundary equation, and this is the rotation value, and I think that I try to plot this, but it shifted a portion, and that's all.